Hi students, today let's discuss about heating effect of current. An electric current can produce three important kind of effects. It can produce a magnetic effect, it can produce a heating effect, and it can produce a chemical effect. So let's see how an electric current can produce heating effect. So when electric current passes through a high resistance wire, it produces heat and the wire becomes hot. In many cases, the wire or the coil can become red hot and radiate lot of heat also. So this phenomena has got wide applications in household as well as industrial uses. This heating effect of current is due to the conversion of electrical energy into heat energy. And how does this conversion happen? This conversion or the transformation happens due to the resistance of the current carrying conductor. So in case we use a conductor which is a very good conductor of electricity, so the resistance to the flow of current is very low. So for very good conductors, this heating effect is very less. But if we use a conductor which has got a very high resistance, so the current flowing through that conductor faces lot of resistance. This generates lot of heat. Now let us assume a high resistance conductor has a current flowing through it. Now this flowing current faces lot of resistance as the wire is not a good conductor of electricity. It has got high resistance value. So what happens? So the potential difference has to do a large amount of work to keep this current flowing continuously. We have shown this by a circuit. We have a high resistance connected to it and we have the battery which is creating the potential difference, and this is the high resistance. So we know the amount of work done will be the product of the charges flowing and the potential difference. And we also know current is basically the total amount of charges flowing at that point of time in the circuit. So we can say Q will be equal to product of current and time. From Ohm's law, we know that voltage is directly proportional to the current flowing in the circuit. So when we substitute the value of Q as IT and V as IR, we get the work done is equal to I square into R into T. So it is the product of the square of the current into the resistance and the time for which the current is flowing through the circuit. Now in this case, let us assume that the work done by the electric energy is converted into heat energy. The total work done is converted into heat energy. So when work done becomes equal to heat energy, so heat produced will be equal to I square into R into T, where I is the current flowing through the circuit, R is the resistance of the conductor, and T is the time duration for which the current was flowing through the circuit. So we get a formula for calculating the heat produced by the current flowing through a high resistance conductor. Okay. So this formula gives us the heat produced in joules when a current of 1 ampere flows in a wire of resistance R for the time t seconds. So this is also known as the Joule's law of heating. So we can say heat produced is directly proportional to the square of the current, the resistance of the wire, and the time for which the current is flowing in the circuit. Now let's do two numericals to get a better understanding of this topic. So the first question says a potential difference of 250 volt is applied across a resistance of 500 ohms in an electric iron. Okay, now we have to calculate the current and the heat energy produced in joules in 10 seconds. Okay. So now calculating the current. From Ohm's law, we know V is equal to I into R, where I becomes, so I becomes V by R. Now it is given in the question, voltage is 250 volt and resistance is 500 ohms. So now when we put this value of V and R, we get current as 0.5 ampere. So this current of 0.5 ampere is flowing through the iron. Now let us calculate the heat energy which will be produced due to this flowing current. So now heat energy, we know the formula, it is I square into R into T. Now it is given the value of T as 10 seconds in the question. So the total heat energy produced will be the value of the current, that is 0.5 whole square into resistance is 500 ohms into current is flowing for 10 seconds. So this comes to 1250 joules. So the heat energy produced is 1250 joules. This is our answer. So we see that a low current of 0.5 ampere flowing through a circuit for very low duration, that is 10 seconds, with a high resistance of 500 ohms can produce an heat energy of 1250 joules. Okay. Now let's see the second numerical. So this says calculate the heat produced when 96,000 coulomb of charge is transferred in 1 hour through a potential difference of 50 volts. So the voltage is 50 and the time duration is 1 hour and the number of charges are 96,000 coulomb. Okay. Now see, let's calculate the current. Calculating the current is, we use the formula I is Q by T. Now value of Q is given 96,000 and the time is 1 hour. 1 hour is basically 60 into 60 seconds. So this becomes 96,000 divided by 60 into 60. So this gives us 26.67 ampere of current. So this amount of current is flowing. Now we need resistance. So now calculating resistance. So using the Ohm's law, we know V is equal to IR. So the resistance will be voltage by current. So voltage was given as 50 volt and current we got as 26.67 ampere. So dividing these two, we get the resistance as 1.87 ohms. So now we have got the current and we have got the resistance. Now let's calculate the heat energy produced. So the formula for heat energy is, we know it is I square RT. So we have the value of current, we have the value of resistance, and we know the value of this time t, which is 1 hour. So putting all this into the equation, we get 4788400 joules. So huge amount of heat. So this is high amount of heat because the current was flowing for 1 hour, for a duration of 1 hour. So the heat produced is also large. So finally the total heat produced is 4788.400 kilojoules. That is 4788.4 kilojoules. So more is the amount of time for the flow of current, the heat produced will be more. It is because of this, if we use appliances like heater, geyser for a long duration, we get a high bill of electricity consumption. So the electricity bill is quite high if we are using all these appliances for a longer duration. Okay students, hope you have understood the concept well. See you in the next video. Till then, please like and subscribe. Also give your comments. Thank you.